been a few days since we talked about multiplying, but multiplying is very much related to what we call factoring. So let me just first of all see what you remember about multiplying. If I told you to multiply, and the multiply was I don't know, 3x squared times x squared minus 9x plus 4. What would you do there? Would you do that one? That would be, well, what's the word on that? Distribute, yeah, all right. So sum multiplying is just distributing a thing. And, of course, distributing the 3x squared, meaning multiply each by 3x squared. Of course, on the exponents, what are we doing? Add the exponents. So it'll be 3x to the fourth for 3x squared times x squared. And then 3x squared times minus 9x. 3 times minus 9 is minus 27. X squared times x, the x to the third, because again, adding the exponents, that's an exponent of 1. 3x squared times 4 is 12x squared. Be the multiply of that thing. Okay. Now, if I multiply 3x minus 2 times 4x plus 5, what's the word? That's foiling. Okay. So sum multiplying is foiling. Foil meaning take this 3x and multiply it by both of these over here. So we got 3x times 4x. That's 12x squared. And then 3x times 5, that's 15x. And then the minus 2 times both of these, minus 2 times 4x is minus 8x. And minus 2 times 5 is minus 10. And, of course, the middle terms here sometimes combine, and these do here, so it'll be 12x squared. And combining like terms, combine the numbers, the coefficients, so we get 7, and then what happens to the variables there? It stays the same, and then the minus 10. Okay. All right, so that's basically what we, a couple of them anyway, most basic ones that we talked about as far as multiplying. Now, why do I bring that up now that we're talking about factoring? Well, what factoring is, by definition, factoring is taking a polynomial and writing it. So writing a polynomial as a product of two or more. So writing a polynomial as a product of two or more polynomials. The basic story is this with the things I've got up here. Factoring involves this. If I want to factor, say, I want to factor that polynomial there, well, what I might wind up doing is getting right back to this. Because, yeah, this is one polynomial times another polynomial, you see. And so that's what I would get if I factored this polynomial. Or if I factored this polynomial, then I would get that. So my point is, the process is the reverse of multiplying. Factoring is the reverse of multiplying. It's unmultiplying, if you will. Another way to put it. Unmultiplying. Okay. Factoring is taking it and breaking it out into factors, into two or more in a product. So this is we're just going to reverse the process. Instead of multiplying it to get this, we're going to factor it and get that, you see. Okay. So how do we do that? There is a little bit little bit of a different way of thinking, I guess, one way we might put it. The way I try to explain it is break it down into the various different types. Just like multiplying, sometimes we distribute, sometimes we FOIL. Well, in factoring, you do similar things. We don't call them those, but we are going to do different types of factoring. So type 1 of factoring is, let's just call it factoring a GCF. Which is going to stand for, any thoughts on that? GCF, greatest common factor. Yeah, it turns out any time you come across a polynomial to factor, this is always what you want to look for right off the bat, very first thing, because I know that's necessarily the easiest, but it is helpful if you note that something has a GCF that can be factored out. All right, so let's just start with one very basic one. And that would be 10x plus 15. Factor the GCF here. Greatest common factor. Well, what that entails, very first step is, of course, identifying the greatest common factor. Yeah, if you think about these two terms right here, they do have something in common as far as factors go, right? There's what common to both of those? What would be a factor of both? If 5 would be a factor of both of those, and so that is there anything bigger than 5 that would be a factor of both of those? No. So we'd say the GCF of the 10x plus the 15 would be 5. Okay? So that's the first step. The second step then is factor it off. So what I'm going to do is put that 5 out front there, and I'm going to take it out of each of these parts, each of these terms. In other words, divide it out of each of these terms. If I divide the 10x by 5, I get 2x. And if I divide the 15 by 5, I get 3. And so that would be factoring the GCF out of 10x plus 15. Like I said, I started pretty easy there, but it gets us going anyway. All right, with me on that? How do I know it's not a negative?
5 and a negative 3.
A negative 5 and a negative 3? Oh, because it's a positive 15? Okay. We'll talk about taking out a negative, but most of the time we are just going to take out a positive 5. Now, I think I know what you're talking about. We'll get to that in a moment, but on GCF, usually it's a positive that you want to take out. All right. Now, what we move up to then is, of course, where we get numbers and variables being factored out at the same time. 8x cubed plus 16x squared plus 12x. What about a GCF on that one? Does that one have something in common? Now, in this case, we've got 3 terms, so when we take out the common factor, it has to be of all 3 terms, right? Here, I've got 8 and 16. Well, 8 goes into both of those. However, 8's not the GCF, is it? Because it's got to go into that one too, doesn't it? So what can I take out of all 3 of those? 4. And then, yeah, the variables, also we have to consider all 3 of them have something variable in them. So, yeah, we have to do that too. 4x, that's right. X is a factor of all 3 parts as well. So we take that out, and so it goes out here front, right? So we divide 4x off of each of these. Now, of course, 8 divided by 4 is 2. What happens on the variables? How does that work? Subtract, yeah. Got x cubed. I'm taking x to the first, so that leaves me an x squared by subtraction. 4x off of that leaves me 4x, doesn't it? 16 divided by 4 is 4. X squared divided by x is x. And then what about here? That'd be 3. Yeah, I'm taking out the x, so there's not an x left over here. 12 divided by 4 is 3. Okay. So far, so good. All right. How about, got another point on this one, 100 m to the 5th minus 50 m to the 4th plus 25 m cubed. Now, let me start on this one. You know, it has a common factor of 5, doesn't it? However, 5 is not the GCF because there's a bigger factor of all three, isn't there? 25. Now, if you start with 5, the thing is you'll just have to do another 5 when you get done taking that 5 out. So might as well do it all at once here. So yeah, we've got a common factor of 25 amongst the numbers. Now, how does it work on the variables? There's an m, sure enough, but can I take out more than just m? I can take out m cubed, can I? Yeah, the deal is, GCF-wise, the variable, you're going to do the lowest power that all three have, which in this case would be m cubed, because m to the 4th certainly has a factor of m cubed, and m to the 5th has a factor of m cubed. So 25 m cubed, does that sound all right with everybody? All right, so if we factor that off of all three, what do we got? 100 divided by 25 is 4, m to the 5th, m to the 2nd, minus 2, m to the 1st. Then what about this one? I'm taking out the 25 and the m cubed. Do I need to put anything? I need to put a 1, yes. Kind of a placeholder. Because I haven't mentioned it yet, but always the check, since we know factoring, we're factoring the GCF, always we know factoring is unmultiplying, so the check, to check your factoring is to multiply it back out. So if I check this, multiply it back out, distribute it back out, which the GCF, that's the reverse of distributing is what we're doing, we should get the same answer. And if I just say here, stop there, and multiply it back out, am I going to get that term back? No, I don't get that last term. So there, like I said, this is a placeholder here because we have to be able to distribute back out and get what we started with. Okay. Everybody all right on that? Now, let me talk about one that has a minus right here in front, minus r cubed plus 15r squared minus 12. All right, I could here, or first point, I do have, as far as the numbers go, anything? 3. There is a 3 in common. What about the r's? Can I take out any r? Why not? I don't have an r here, so I can't take it very well. Take out an r out for my GCF. Everything's got to have an r to be able to take out an r GCF. Now the other thing here, that would be fine if I just did 3. However, because this first term is negative, my strong suggestion is let's also take out for the GCF a negative as well. Different reasons for doing that. Like I said, it's not wrong if you don't, but I would strongly recommend it for later purposes anyway. All right, so with me on that, since this first term is negative, the largest power term, I'm also going to do a GCF that's negative. So if I do a negative 3 GCF, of course I'm dividing now by negative 3, so that makes it a what? Positive 2, and the r cubed stays the same. Now divide that by negative 3. Makes it a negative 5 r squared, and that by negative 3, the negative 12 makes it a positive 4. So all these signs basically get changed because I took out that negative there. Okay? All right.